Hello, and welcome to Beyond Biotech, the weekly podcast from Labiotech. I'm Dylan Kassane, and this is episode 196 for the podcast. Today we dive into the future of lab management with Ryan Cawood, CEO and co-founder of LabThread. Ryan's journey spans groundbreaking work in virotherapy and gene delivery during his DPhil at Oxford to founding Oxgene, a cell and gene therapy innovator acquired by WuXi Advanced Therapies in 2021. We'll explore the frustrations of fragmented lab tools that inspired LabThread's integrated digital solution, combining ELN, LIMS, molecular biology, and collaboration in one seamless platform. We'll uncover how it boosts reproducibility, ensures compliance, and frees scientists up to innovate. I hope you enjoy Ryan's insights on evolving digital workflows and accelerating breakthroughs in the lab. Ryan, welcome to Beyond Biotech.
Thanks, Ellen. Nice to be here.
Ryan, walk me through your career in biotech, starting from the time when you were over there in Leeds.
Before the career in biotech, there was the career in academia. Started my undergrad in Leeds in genetics, then moved down to Oxford, did a PhD there in virology and oncology, finally sort of moving into the gene therapy space. That was the sort of academic career. And then I think perhaps rather naively, immediately after finishing the PhD, I decided to start my first biotech, knowing absolutely nothing about business or how to run a company. That was kind of a baptism of fire, to be honest.
You founded Oxgene and you were there for a decade. You must have learned plenty during that time.
Yeah, absolutely. And I wouldn't necessarily condone the methods that I used, in the sense there was a lot of YouTube videos, a lot of scouring the internet to try and figure out, how do you understand balance sheets, cash flow forecasts, and legalese associated with investments. But I ran that company for 10 years as the CEO. We grew the company to probably about 110 people. We sold the business back in 2021. It was a long journey. It was a fun journey, but certainly learned a huge amount along the way.
I mean, there's a lot to learn on the business side, and that can be frustrating, but there must have been frustrations there in the lab too, because these were first generation digital tools you would have been using, ELNs, LIMS, software for molecular biology. That must have been a bit frustrating too.
Yeah. I mean, very, very frustrating, to be honest. And it sort of take us back to 2011 when I started the company. The company was doing a huge amount of genetic engineering, and I had to basically manipulate large amounts of sequences, and there really wasn't any software that was around at the time that would allow me to do that. And so back in the day, I was, if you can believe it, I was sort of genetic engineering in Excel and Microsoft Word at different times. So it was quite a special experience to batch edit, 2,000 plasmids in Excel.
So what were the sort of day-to-day frustrations that you were facing there in the lab at the time, beyond the software, but what were the frustrations you were facing there, and as everybody was just trying to keep their work organized, I guess?
Yeah, and I think the problem changes, and I think anybody that goes through a growing biotech will experience this. When the group is small, let's say 3 to 5 people, you can talk to the team every day, right? You can go in, you sit in the same office, you collaborate, communication is easy, you know what everybody else is working on, and then the company becomes 10 people, it becomes 15, it becomes 20. There's more lines of management. If things start to get a bit muddy and that people are not necessarily sure what everybody else is working on, collaboration gets more difficult, and then it gets to 50, it gets to 100 people. And then you have this sort of, the people who are working at the lab don't necessarily know what everybody else is working on. You get people, managers want to know about what their staff are up to. The complexity just amplifies as the company gets bigger.
And I mean, everybody's got tools, and I know in that growing startup area, you start with the tools that the 5 or 10 people working there like the best, know the best. And then as the company grows, the tools sort of grow as well. Everybody's got their own software, and suddenly none of them are talking to each other. Can having all of these sort of tools just slow the research down?
Yeah, I mean, certainly there's certain tools that work really well on a sort of individual basis as a scientist, and then there's some that work as well as a small group, and there's also tools that then start to creak as things, as companies get larger and collaboration gets more important. So, yeah, I mean, definitely the tools have to evolve. And what we were doing at my previous company is we ended up actually building a lot of custom tools. So, we would sort of scour the market, look for what was available, whether it be for sample management, project management, electronic lab notebook recording, things like that. And in the end, we started to actually build our own tools in-house, just because we were trying to bind these things together in a way that allowed the entire company to collaborate.
I mean, building them in house, that comes with a cost, obviously, in
Yes.
development.
Yeah.
But
Yeah.
are there also costs to not doing that? Would it slow you down? Would it just not work?
Yeah, yeah, absolutely. I mean, I think you get a huge amount of loss when you lose individuals from, when they move on from a company. And if you've not recorded everything, if you don't know where everything's stored, it's incredibly expensive. You invest in training people up, they invest in your company and support the work that you're doing. And, you might end up with 2 or 3 years worth of work that they've invested, that you've invested, they've invested. And you need to ensure that if they do move on from the company, that you've got a full track record of that. Otherwise, it's very expensive to lose that.
I think you always have that track record, but it's hidden in Outlook, or it's hidden in Excel, or
Yeah,
it's on a folder that had a very
or
special name for
paper.
them that no one
Worse.
else can find.
Yeah, yeah, exactly. I mean, worst case scenario is paper, right? You've got a sort of a lab book that is perhaps well curated or not, and then your other example is the sort of a uniquely structured file structure that stores their data in a way that was understood to them, but perhaps not necessarily understood to everybody else. And I think that's where the challenge comes because people join a company and join a scientific group. They bring, like you said, they bring their own historical software, their own methods of recording their data that they learned perhaps when they were doing their PhD. And so, unless you can somehow standardize that in an organization, it gets really hard to then navigate it if that person's no longer there.
Can we put a number on how much time is actually lost to this sort of administration, the paperwork, the hunting for information, rather than actually doing the science?
Um, it's pretty hard to put an accurate number on it because it's you're going to have a varying degree of quality of how people store their data, right? I mean, so I think maybe like this morning I was looking for a file and I was trying to type different words into my email client to try and find that email that I knew was attached. The file was attached to the email, and I was there for about 20 minutes. It was driving me absolutely mad. And it's just a small example of how things can end up. Somebody says, "Oh, I'll send you that data," and then they ping it to them, and then that's the only record that they've collaborated on that piece of data. And then you spend, an hour, 2 hours digging through your email client trying to find these things. Yeah, it's expensive in terms of time, but also just in terms of mental anguish. I think the amount of hassle of looking for these things when there should be a more efficient way to do it.
And I guess especially for really small biotechs where the headcount is 10 people, 5 people, there's just not enough time or there's not enough money to have people looking around for these things all of the time.
Yeah, yeah, no, absolutely. And time is very, very precious, right? So it's in the UK a few years ago there was this sort of thing about police forces spending all of their time filling in paperwork, not being out there solving crimes and things like that. It's the same in the lab, right? You don't want your staff spending all of their time filling in forms, filling in paperwork, and if the piece of software and the tools that you're asking them to use add that overhead, that's expensive for you as a company, but also expensive for the scientists because they want to be getting on with the job in hand. So it's a delicate balance, right? You're trying to make sure that as a business and even as just a research group, in academia, that you're trying to ensure that you get the data recorded, but in a way that doesn't break the company and the workflow, and ensuring that everybody is actually able to get on with the job in hand. So it's a really difficult balance. But yeah, as a small company. I'd say that with a small company, things can be a little bit more ragged in the sense that you're able to do that because, like I said, everybody can kind of talk to each other and everybody can communicate quite efficiently. I think if you don't lay the foundations though in that small company, then it gets more and more difficult as the business grows.
And there's always that scary size of the company, somewhere between 30, 40 people where you can still get together and everybody can talk, and that 110, 120 level where suddenly there's layers of management in there. That just becomes hard to deal with.
Yeah, it does. It is, it's where inefficiency starts to creep in, and where, like you said, you've got multiple layers, multiple tiers. People have got their groups, and the different groups are perhaps not gelling and collaborating as well as you might like. And sometimes you have to make structural changes within the company. It gets difficult, and I think the more you can foster collaboration, the more you can ensure efficient lines of communication, the better. But I think you constantly have this pull as the company gets bigger. So you have the pull of the senior people in the company wanting to know what's going on. Right? They can't do their job unless they understand where the research is at, who's working on what. So you've got that's sort of the sort of top down view, and then you've got the other pull, which is like I've just sort of mentioned. You've got the scientist in the lab who wants to be as efficient as they possibly can, and don't want to have to continually be filling in lots of things that fundamentally are needed to ensure that the people that are managing everything can see what's going on. So I like to sort of compare it perhaps to like if you were in a busy kitchen, a chef, and you ask the chef to write down everything they're doing, right? So every meal they're making, they have to write it down, how many potatoes they use, what the temperature of the oven was. I mean, you would drive a chef mad, right? If you told them they had to do that. But that is exactly what we expect of a laboratory scientist. And so the pressure is significant to record all of that piece of data, all those data points. But if you make it any harder than writing it down, then they're going to get annoyed. And so that's the challenge that you have. You're trying to make sure that they do record the data, but at the same time, not trying to add such an overhead that they can't continue to do the work that they need to do.
So you saw all of this in your time at Oxgene, and you saw it as the company was growing, all of the challenges that you had there. And I guess that brings me back to where you are today at LabThread. Tell me how you came up with LabThread.
Yeah, so I mean, it was sort of fundamentally sort of realizing that we need to connect everything together within the lab, right? And I think we try to do this anyway, through, having project management meetings, having, talking with each other. We're inherently trying to do that all the time, but it's just really, really difficult in biosciences. And, an example you might take, for example, is let's say that you're trying to make a stable cell line. You're trying to genetically engineer a stable cell line, right? If we trace it all the way back to the origin of genetically engineering that stable cell line, let's start from the very beginning. So you're going to order some primers. You're going to order them from a DNA synthesis company. They're going to arrive. You're going to use them in a PCR reaction. So you're going to now make a linear piece of DNA that you might do something with. You'll clone that into a plasmid, let's say, for example. So now you've gone from a linear DNA molecule to a circular DNA molecule. You're going to purify that. You're then going to introduce that into maybe some cells to make a viral vector. So now your linear DNA molecule has become a circular DNA molecule, has become a viral vector. You're now going to use the viral vector to transduce the cell line. So now the virus has gone into the cell. You're now going to passage the cell for the next 3 years. You're going to show it's stable. There's this chain of custody, right, of the materials that are passing from one thing to another. And the problem is they bifurcate each time. That plasmid could go into 4 different viral vectors. The cell line could get passaged and passed to 5 other individuals. And so you're constantly trying to track and trace all of these different descendants, and doing that in the laboratory for bioscience is just incredibly difficult, because it's not one person necessarily doing all of that, in charge of that chain of custody. And so understanding what's been done when in our industry is just incredibly difficult. It's just a really significant challenge. And that was the sort of principle behind trying to build LabThread in a way that could compensate for could allow for that. But also just, building in things like collaboration tools. So, for example, there's like a project management tier over the top of it, so that the people who are more senior in the company can understand what's going on. Being able to build like commenting functions, so you can have an actual chat, not on WhatsApp, not on Teams, but actually in the product where you're storing the data itself, so that is all captured as part of that journey. And so that was the principle behind LabThread. And, so it's really trying to bring everything together. So trying to understand how the lab is working, trying to ensure that the things that are being done are being recorded in a way that you could go back 2 or 3 years and be able to know exactly what happened.
When I was looking over the website, I could see that LabThread combines, and I'll just say, molecular biology tools, bench-side calculations, ELN records, sample tracking, data analysis, team feedback. Everything is there, and I got to say, it sort of sounds amazing in theory, but in practice, is it something that actually works? Does that integrated workflow actually work?
Yeah, I mean, I think you're absolutely right. It's incredibly complicated. We've been building, breaking down and rebuilding many of these components multiple times over. And the first, some of the first instances that we built of some of these components just didn't work for what we needed because it either didn't dovetail into the other parts of the system, or the overhead of usage was too much. Like I was saying earlier about, the scientists are going to hate this, so we need to simplify the interfaces. So does it work? I mean, that's for the scientists to tell us. I think we shall see how things evolve, over the next few months and years. It's certainly from my perspective as sort of, one of the overarching architects of trying to figure out how these parts talk to each other. I feel what we've built is something that is really useful from a scientist perspective. But of course, there's always the risk that you're clouded by your own, you swallow your own Kool-Aid type thing. So I'm hoping it does, and it seems to. It has everything that I wanted it to have, at least as a starting point. But yeah, I think it's going to be for the scientists to tell us whether they think it delivers or not.
Is there a secret sauce here? Is there something that differentiates it from other products out there on the market? Something that makes people just sit up and go, wow, that works?
I think there's certain parts to it. I think there's certain parts that are unique to it. I think the molecular biology part of what we've done, I think, is really quite advanced, and I think will allow people to have to move away from some legacy software that they've used historically. The ability to overlay the project management on top of the entire workflow, I think, also adds something that you don't really see in other products. I think the user experience is hopefully something that people are going to like. I've spent a huge amount of time just sitting with different interfaces in front of scientists and saying, what do you think that button does? What do you think that button is? The button the right color? Like very basic, simple stuff to try and make it a nice product to use rather than it just being, a piece of functionality that perhaps is difficult to navigate.
You talk a lot like a software developer now more than a scientist. But you're asking these questions of scientists, and you're building on frustrations that you had yourself when you were a scientist. Was there a time that you just sat around with your co-founder and just said, someone's got to do something about this, and eventually you realize, well, it's going to have to be us?
Yeah. Essentially, I mean, like, when I left Oxygen, my previous company, it was a conversation with my co-founder Dan, and we were just kind of saying like, still doesn't feel like it's been solved in a way that I think, I'm not saying that everybody that's going to sign into LabThread is going to love it, but I don't meet scientists that say that they love their software that they're currently using. It doesn't happen often. I might be wrong on that, but maybe it's just the scientists I've met. But we want to build a piece of software that people love, and so yeah, I feel that that was the opportunity, and I felt that it hadn't quite been solved by the current systems that are available. And yeah, so Dan and I sort of took it on the chin and decided to go for it.
Let's talk about the software in practice then. One of the things that can be really difficult to do is to reproduce an experiment or reproduce a protocol if you haven't got all of the information there, and little bits are lost in Outlook folders, Excel files, or in lab notes. How do you actually improve reproducibility by having this whole history there linked together? Does that actually change the function at all?
Yeah, I mean, I think this reproducibility, I think, comes from a couple of different areas. So one is firstly being able to access the data, right? So being able to know who did what when. The other part is ensuring that people are recording it, right? If it's not been recorded, then you're never going to know why perhaps this day, your experiment this week didn't work and my experiment next week did. And that can be very subtle things. It could be a water bath was 36 degrees and this week it's 38, or it could be that the incubator's CO2 level is wrong or something like that. And so, unless you record things, it's very difficult to understand the differences. And the only way you're going to record things, like I was sort of saying earlier, is if it's easy to do so. If it's difficult to do so, you probably will just skip it. I know scientists, when I say to them, show me when you did this, and they say, oh well, I just don't write that down because I do it all the time. And so you've got to have the data first to then be able to figure out why something did or didn't work. And that kind of fits in with part of the ethos of LabThread. So, you can build templates. Those templates can be used consistently. You can share them across the entire company. You can make them read only. You can give them editor rights. You can control the degree to which you allow people to deviate from these things and sort of go rogue and make changes if you want them to or not. But we're also building another tool, which will be launched in a few months, which is called Processes. And that's basically allows you to create like standardized forms designed to be used on an iPad interface or something similar to an iPad. that within a couple of clicks, you can record the things that you do all the time. And you just have to then record the deviations. So, for example, if I was making a cup of tea, right, I might have a form on my iPad in my kitchen and I click, the kettle is heated. Today it heated to 98 degrees, and that's fine because normally it says 100, but I've changed today to 98 because that's what it was. The milk was expiring in 4 days. The tea bag weighed 12 grams, whatever, what you can record. These things are all there as defaults, and you can just note the deviation. And therefore, within a couple of clicks, you can record something that perhaps historically you wouldn't have recorded, but because it's now easy to do so, you can capture that data. And what that means is that after a year, you could go back and you could say, okay, well, tell me what was different every time my cup of tea tasted terrible. And it could say, well, based on the fact that every time you did it, when the kettle was 98 degrees, you reported that the tea tasted terrible. Then you can then understand the reproducibility of what makes a good cup of tea. And the same applies in the laboratory. It's exactly the same principle. So I think firstly, you've got to give people the ability to be able to record it in a frictionless way. And then you've got to overlay on top of that an ability to query that data to say, okay, well, over the last however long, when Ryan did this or Dylan did that, why did this work and why did that not work? And that's kind of the next layer, next direction of travel for LabThread, is to sort of build in AI tools so that we can actually start to query the data in a consistent way.
What about when it comes to standards and compliance? I mean, for companies that are trying to align with standards like ISO 9001, ISO 27001, how does it help them to achieve those sorts of goals?
Yeah, I mean, again, like 10 years ago, you'd been printing out pieces of paper, you'd been signing them, you'd have had manual sign off by a second reviewer, things like that. You can catch all of that now in the software. You can send a piece of data for review. You can come back to you with a critique or a comment. You can then send it back and have that sort of back and forth of review, and then you can lock and record the data. But also having that provenance, the ability to see where things have been, where they've been used, who's used what, when, full audit trails, all that sort of stuff. It makes it much easier. Of course, it's very much proportional to the work you're doing. If you're in a small research lab, you're not going into the clinic, you're just studying something for the scientific interest of it. Those things may not be as critical. But if you're taking a therapy into the clinic, it's essential. You need to understand where these things have gone and what's been done to them.
What about those researchers in the lab? Does it help them with collaboration if you pull them out of their inboxes or out of their Slack channels and actually put them in a single piece of software and get them to talk?
Yeah, no, definitely. I think it's much easier if you're having that collaboration and that conversation in the place where the data is stored. I think that's inherently easier to have that conversation, and that's one of the things we've built into the system is that you can basically chat at different levels. So you could chat at like the project level, you could chat at a task level, you could chat at about an electronic lab notebook. You can have a separate chat about a particular DNA sequence. You can have a chat about a sample if you're particularly excited about a sample. There's different tiers at which you can collaborate, and you can imagine if you're doing that by email or you're doing that in Teams or Slack, that it's very flat in that sense. It's not, you're not going to create a Teams or a Slack channel for one sample or one DNA sequence, and so it gets lost in the noise of the more general chit chat. So I think it'll benefit from that perspective. You'll come back to a DNA sequence, and in 2 years you can understand, well, why did we design it that way, and why did we do it the way that we decided to do it, and you can kind of see the evidence of that. So I think that will make a big difference.
You mentioned a second ago the people perhaps working in a university lab or a fundamental research lab. They might not be interested in all of the features of LabThread, but is there a non-commercial option? Is it something that a research lab at a university might use too?
Yeah, absolutely. I mean, I think all the tools cross over, but you're right that probably they don't need some of the tools that we've sort of been discussing or that are available in the system. But yeah, we offer a free version for academic labs. Up to 5 scientists can collaborate in a small group, which probably covers, a significant proportion of academic groups. But they're using samples, they're recording their data, they're doing project management. All of these things are shared between both biotechs and academia.
Okay, so your live version, it went live a couple of weeks ago now. You must have got a heap of feedback during the beta testing phase, and now you're getting feedback that it's live. Has that helped develop the project in itself?
Yeah, massively. And I think when we released the beta version back in very late 2025, we had a very clear development path leading from that beta release to the live launch, which we did in April. And thankfully, when we first launched the beta product, the things that people are immediately asking for were the things that we were already working on, which is encouraging because it means we weren't completely off the mark. Obviously, slightly challenging for those beta users because they wanted those features immediately. But yeah, that's been encouraging. It's sort of validating the weather vane of what we think needs implementing and what needs adding to the product. But this for us is a mark in the sand, it's a line in the sand. We've released the product with the components that we define as the sort of minimum set, but there is a huge amount more that's coming. There's a lot more features that we want to build, a lot more features that we want to add. And so, it's exciting from that perspective. If people like what we've already done, then hopefully in 3-6 months from now, when we're releasing additional components, then they'll be even happier with the new things that we're adding.
For labs who feel all of these same frustrations that you felt before, they're considering transitioning from a paper-based or some sort of fragmented digital system into a single platform like LabThread. What sort of advice can you give them there? What should they be looking at? What should they be expecting from a product like LabThread?
Well, I mean, I think a couple of my sort of frustrations as a purchaser in a company have been over the years is just sort of the barrier to trying something out. Some of the other software that's available on the internet is difficult to get into and to test and to try. I mean, you can go and sign up to LabThread now and you get 30 days for free. You can play around with it. If you like it, great. Then you can choose a subscription, and it's the barrier to trying it. I want it to be as low as possible. And so it's I think in terms of what they can expect from it, they can hopefully expect something that is user friendly, that provides that collaboration function, but with the ability to store their data and samples in a way that hopefully makes sense to them as a scientist.
Looking ahead, how do you see this digital lab management sector evolving within the broader biotech industry?
I think we're good. I mean, I know probably I'm not sure how many podcasts you've done on AI, but I imagine you've done a few. I think there's going to be the way I've been building LabThread with the team is let's get the product itself right, and then we focus on the AI implementation after that. So I think what you're going to see, and that's not just us, I'm not suggesting I've discovered alchemy or anything like that in proposing that. There's what I've tried to do is ensure that the product itself is fundamentally delivering what we wanted it to deliver, and then the next 6 to 9 months for us is how do you evolve that to add things on top of it using AI that can make scientists' jobs much easier. That's where I think it's going to go. Process, like you were saying about querying in a way that you couldn't before. So you could say, generate me a report on this particular project. How's it going? Give me the overview, or find me any samples that relate to this particular piece of work. Or you can. I think there will be a lot of improvement in the efficiency with how people can access data, how they can generate reports, how they can collaborate, and I think AI is going to help with that quite a lot. I think that the amount of data that people are generating now is also huge. There is a data handling issue in the sense that some experiments can be generating, terabytes of data from complex Z stacks of microscopy and things like that. And I think that is a data management issue. And I think increasingly software providers are going to be requested to be able to act as a data storage vehicle as well as a place to, like I was saying, collaborate, project manage, whatever it may be. And so I think that will change, because at the moment that the consequences of not allowing for large amounts of data to be stored in your platform mean that you end up with siloed data. You'll have it be stored locally, perhaps in the laboratory, or be on a hard drive here and hard drive there, and maybe in Dropbox or something like that. So I think if we can start to enable that, then that will improve the way in which we bring all the data together into one place. So I think it's a combination of AI allowing these larger data sets to be stored, and in being able to query them in a way that gives you meaningful results.
One of the promises of AI, I guess, is that things will move faster and that it'll be much more efficient. There's some debate on how true that promise actually is. But do you imagine a tool like LabThread is also going to accelerate science in some way?
Yeah, no, definitely. I think it will do. I mean, I think it'll accelerate the speed with which. I mean, my first fundamental principle is accelerate the speed with which people can get data in. How do they record their data in a more efficient, quicker way? So I think AI will play a part in that in the future. But I think the software itself, a fundamental thing I've been trying to build into it is to make it easy for scientists to get the data into the system, so it doesn't add overhead and it doesn't add friction. So yeah, but there's also that, that sort of secondary benefit that, like I was saying, if you're trying to find something from somebody that's left a year ago, at the moment, it could take you days. You may never find it. You may never find that data. So in terms of speeding things up, the hope is that being able to access that data and understanding where it is located quickly will obviously help to speed everything up.
Ryan, for people who want to learn a little bit more about LabThread or want to try out this new software, where's the best place for them to go?
Yeah, I mean, just labthread.com. You can click on there. You can sign up to the product there. You can, you create an account, which is your company or your academic research group, and then you invite your other colleagues to collaborate, and then give it a go.
Ryan, thanks for talking us through all of this today. I appreciate your time, and thanks for joining us on Beyond Biotech.
Thanks, Dylan. Really appreciate it.
That's it for this episode. Don't forget to check out all the latest news and analysis at Labiotech.eu. I hope wherever you are in the world, you have a great week ahead. Thanks for listening, and I hope you'll join us again next time for another Beyond Biotech.